Welcome to Mrs. Neller's notes for her double block algebra class. These are the notes for section 4.6 entitled Direct Variation. And today we're going to talk about finding the value of the direct variation constant, which is called K. We're going to write and graph equations that represent direct variation, and we're going to use direct variation to find a certain value. Now when two quantities, we'll just call them x and y, have a constant ratio, we're going to call that ratio K, then they are said to vary directly or have direct variation. So what that means is if we have two quantities in a ratio, like 2 over 4, that would reduce to 1/2. Or if we had two other quantities, 3 over 6, those also reduce all the way down to 1/2. Or you could have 5 over 10, that reduces down to 1/2. So all of these numbers that I'm picking, all of these quantities that I'm picking and putting in a ratio, all reduce down to the same constant ratio of 1/2. So that is their uh, ratio of direct variation, or their direct variation constant. Okay? So that's what we're going to find in example 1. We're going to find the constant by which these two variables are related to each other. So part A says y varies directly with x, and y equals 40 when x equals 4. Now, there's an equation that we're going to use for direct variation. And it's always going to be y equals k times x. And that equation is always going to look that way. It's always going to have y and k and x. Now k is going to be our constant, and then x and y are going to be the numbers that we will have values for that we will substitute in. So that's the equation that we're going to use here. When it says y varies directly with x, that means we want to use this equation. That's what this first part of part A means. And then they give you a couple values. So they tell you y equals 40 when x equals 4. So you're going to put 40 in there for the y and 4 in there for x. And then you can actually solve this for k. So I'd have to undo that multiplication by 4, so I have to divide. So now my constant of variation is 10. So let's try that again for part B. It says y varies directly with x, so that means I'm going to use this equation, y equals k times x. That's my equation for direct variation. And now it tells me that y is 9 when x is 27. So I'm going to put 9 in for the y and 27 in for the x. And then I can solve for k. Now, I want to divide by the 27. A lot of times when students do this, they take 27 divided by 9 and they get 3. But this is 9 divided by 27. So you want to reduce that down to 1/3. So for part A and for part B, we have some kind of variables. We have some constant relationship between them. And that constant relationship is that if you took the x value and multiplied it by the 10, you would get the y value that corresponds to it. Or for part B, if you had an x value and you multiplied it by 1/3, you would get the y value that corresponds with that x value. So now in example 2, they're going to want us to write an equation that relates x and y. And when you want to write that equation, remember we're using the y equals k times x. But in example 1, we found the k, we found the constant. So in part A, I would rewrite this equation, but I would put a 10 in the place where the k is, because I found the constant between 40 and 4 to be 10. And for part B, I would rewrite that equation, with a constant value of 1/3. Okay, so that between example 1 and example 2, it's breaking down the big problem that you're going to have to work with. And it's breaking it down into 2 steps. A lot of times they're going to have you find the constant and then rewrite the equation. Okay. Now before we do problems like that though, we're going to talk about graphing them. And a graph of a direct variation equation is always a line that goes through the origin. It always goes through the origin. And when we graph these, you can just make a table of values to graph them. Okay, for part A here, let's see, let me squeeze in a table of values over here. I've got X and Y. And I'm going to pick some negative values and some positive values. Okay, so -3 times -1 would be 3. -3 times 0 would be 0. -3 times 1 would be -3. -3 times 2 would be -6. So those are my values that I'm going to put on my graph so that I can get a picture of the direct variation equation. Now my line's going down, and that's good because here in my equation, y equals -3x, I had a negative in front of the 3. So that tells me that my line should be going down. And notice that I went through the origin, 0, 0. It's a value that's in my table of values. Okay? So even if you don't remember that these are direct variation equations, you can still make a table of values and graph them. So for part B now, I'm still going to make my table of values with x and y, but I want to be a little more strategic in the types of numbers that I pick now for x, because my equation is y equals 1/2 x. So whatever number I pick for x, I'm going to have to multiply it by a half. So I want numbers that I know I can take half of, that I can divide by 2. So let's pick -2, 0, 2, and 4. And again, you need at least 3 values. I'm just picking 4. So half of -2 is going to be -1, half of 0 is 0, half of 2 is 1, and half of 4 is 2. And again, notice I've got 0, 0 in my table of values. That's one of those characteristics that's always going to happen when you have a direct variation equation that you're graphing. There we go. So when you're graphing these equations in your homework tonight, if they don't go through 0, 0, go back and double check your work. Now this line was going up, and that's good because our constant was positive, so that tells me my line should be going up. So that's a way that you can double check your work. Okay, last concept then. We're going to put all of this together. We're going to find our constant and then rewrite our equation and then find another value. So it says the distance a spring will stretch varies directly as the amount of weight attached to it. If a 5-pound weight stretches a spring 2 inches, how many inches will a 3-pound weight stretch the spring? Okay, now this first sentence here tells us how to write our equation. It says the distance a spring will stretch varies directly as the amount of weight attached to it. So we're still going to use that y equals k times x equation, except I'm going to modify it just a little bit. It said that the distance varies directly with the weight. So I'm going to make my y into a d for distance. And then when it says varies directly, I need to keep my k times, and then the weight is what I'm going to use in place of the x. Okay, so now that I have that equation, my second sentence tells me what to substitute in. If we have a 5-pound weight and it stretches the spring 2 inches, okay, so I'm going to stop right there. I'm going to take this equation and I'm going to substitute some stuff into it. The 5-pound weight, that's how much weight we had. K is going to be K, that's what we're going to find. And it stretches it 2 inches. That's my distance. So now I'm going to solve this for K. So 2 over 5 is my value for K. So now I'm going to go back and I'm going to rewrite my equation. Instead of D equals K times W, I'm going to write D equals 2 over 5 times W, because I know what that constant value is now. So now that I have my equation written like that, I'll be able to solve it for any scenario that they give me. And the rest of this problem is the next scenario that they give me. How many inches, so that's what I want to find. I want to find that distance. Will a 3-pound weight stretch the spring? So that 3 is what I'm going to put into this new equation for the W. So I'm finding my distance. I still keep the 2/5 because that's my constant. And I'm going to multiply it by 3, or 3 over 1. So that will get me 6 over 5. Now it says how many inches, so we don't usually say 6/5 inches. So you could say 1 1/5, or if you wanted it as a decimal, you could say 1.2 inches. So here it's good to take a moment and think about the best way to represent your answer. So this is about as complicated as the problems are going to get, where they want you to write the equation, find the constant, rewrite the equation, and then use that equation to solve for a certain amount. So what 2 types of variation are there? Well, we have, 2 types of direct variation. We can have positive direct variation, or we can have negative direct variation. And that's like what we saw in our graphs, where we had one line going up and one line going down. Okay, so here are your homework problems so that you can practice these concepts. And if you have any questions, come on in and see me before school.